Hi, this video is going to cover hashing and digital signatures. This is part of the Romney Accounting Information Textbook, Chapter 9. If you are using a condensed book, that would be then Chapter 6. So we're talking about how to protect confidential information or private information. Once again, the process is the same for both. So one of the tools we want to use is hashing. And this checks to see if a file is the same when it gets sent versus when it is received. So you take any file and you convert it to a hash code, sometimes up to 256 bits. So I have here an automated hash code that you can find these online. All you do is enter some text. And there's several different algorithms. We're just going to pick 256. That will generate a 256-bit hash code. And then we see the code. So that code, along with the document, are sent together to the recipient. If we make any small change, like just add a space and regenerate the hash code, you notice that it changes. So if the file changes anywhere along the route, this hash code would be different, and the recipient would be able to tell that somehow the file has been changed. Now the note with hash code versus encryption is once you have a code, you can't really convert that back to text. There's no way within that code we know exactly what the message was. So if somebody obtains that code, they are not able to convert it even with any means. So the two are sent together. If the hash code differs on the recipient side from when they regenerate it, then we know that something happened in the file. It may not have been fully transmitted, or somebody hacked it and made a change in the middle. Now this is used to help generate digital signatures. So think of a digital signature as an electronic signature that helps authenticate who actually sent the document. So it's kind of a proof of identity, so it's a form of authentication of a sender. So not authentication of who can log in. So what happens is the senders make a hash similar to what we did with that short message. They encrypt this hash and send with a private key. So this is actually the digital signature. And actually, so we can see this on figure 3 and figure 4 on page 189 in the short textbook. So both this document and the encrypted hash, which is the signature, are sent to the recipient. So when the file is received, the recipient takes a hash of that same document and using the same algorithm and sees if it changes. They must decrypt the hash that was sent in order to be able to read it. Once this comparison's done, it helps prove that the document was sent by that sender with that user's private key. If the two hashes match, we know we're okay. The figure in your textbook that really helps kind of describe this shows a contract. So party X creates the contract and puts it through a hashing algorithm. So they get a 256-bit code. So that hash is encrypted and sent with the contract. The contract is probably also encrypted as well. So that's the digital signature is the encrypted hash. You send it to the second party who receives both documents, the contract and the digital signature. So they hash the contract again, and then they decrypt the digital signature to get the hash that was sent. If they match, we know that the contract is correct and was sent or received as intended. If not, that we know that either X did not create the contract, or in this case, because we used the digital signature, it was also corrupted. So one of those two conditions, either it truly was not sent by X, or it was corrupted during transmission. couple other things that we have to talk about. A digital certificate. This is some type of authentication sent by a third party, a trusted third party, so a certificate authority that helps identify that yes, this document is the owner of a public key. So for example, you have a public key on your hard drive, probably of any bank you use, of your credit card, of LinkedIn, of Amazon, and this third party helps identify that that is truly the key from that organization, because there's many websites that are spoof websites that look fairly close to the original. This way we know we're on the original site. Think of it as a passport, a driver's license, or any authenticated document from, for example, a government agency. Along with that, there is a system to use and issue keys, and that is part of our public key infrastructure. So they actually just issue key. If you need a new key for encryption, they're issued, and they help maintain those, as well as the digital certificates. Well, this concludes what I'd like to talk about today. Thank you very much.